Meanwhile, so we have these bus systems which work fine, but then began to be have problems as things got faster. Alternative, at the same time, I shouldn't say alternatively, at the same time, there was a whole new technology that explicitly dealt with distance communication, transmitting information over a long distance, where all the assumptions that were okay for a bus-based system but then began breaking down never held in the first place, transmitting information throughout a whole building. So this notion of how to create a network, which in some level has the same job as the bus, started dealing with these issues of transmitting information reliably over distances to many participants. It took that sort of as one of the things it had to solve from the get-go, rather than just discover it 10 years in. And so there's this notion of sort of being inspired by how radio transmissions work, and doing the same thing, but confining the transmission not to the ether, but to a wire, so that we could, in a sense, the trouble is if we broadcast it, first of all, that's a whole separate set of technologies that we have to, the transmission technologies, antennas and things like that we have to worry about. But we run out of bandwidth. In other words, there's only, the ether only has so many, umpty-dump, gigahertz, terahertz, or whatever it is, so many hertz of bandwidth. And if we had, we'd use it all up. The advantage of wires is we can build as much bandwidth as we want. If we just yell in the wire, if you want to make, yell to your friend, you can just have a separate wire between you, and our communications don't have to worry about sharing some, globally, shared medium. So this was a really neat idea. So we had cables that replaced the transmissions, but the basic idea was the same. And we, the whole notion of breaking information into packets and transmitting it in little chunks so that we could sort of verify the arrival of each chunk separately, and if a chunk went missing or went bad, we could just send that little chunk. From the get-go, it was built in that these communications had some unreliability. And the whole architecture of the communication system, both at the hardware level and at the software level, was carefully designed to account for these failures, right? It was also designed to accommodate technological change. So the notion of building a network that could run equally well on an IBM token ring or one of these Ethernet things that were just coming out in the 70s. People began to say, look, I want to be flexible. I want to use the best network that's available to me. There's actually many networks out there, so I want to start building my software stacks. And they thought carefully about what the levels of abstraction were. But this sort of modularity, both in terms of thinking about failure in the basic system, but building a system that can be expanded with more and more customers, and then reflecting necessary modularity in the software to sort of insulate yourself from technological change. That was all pretty insightful. And in fact, the system architects who were building the big CPU boxes should have done the same thinking, but